this example, we're going to use technology to solve a rational equation graphically, and we're going to approximate our answers to the nearest hundredth where appropriate. Okay. All right, so the equation that we're given is 5 over x squared plus 7 equal to x plus 2 over x minus 3. So if we were to go to solve this by hand, we have denominators of x squared plus 7 and x minus 3, both of which are fully factored. And we can't do anything but multiply them together to get the LCD. So when we multiply both sides by the LCD, the right-hand side with the x plus 2 times x squared plus 7, that's going to be a cubic, right? Which is difficult to solve by hand. So let's go to Desmos. All right. So in Desmos, I'm going to enter the left-hand side of the equation, which we'll enter as y equal to 5 divided by x squared plus 7. And then we'll graph the right-hand side of the equation, which was x plus 2, get parentheses around the x plus 2 there, divided by x minus 3. Okay, so we see that we've got two graphs here, right? And we want to know where they're equal, right? So what we're looking for is where do they intersect? Where do both sides of the equal sign essentially intersect? And they intersect right at that point right there, okay? You might ask the question, well, is this the only intersection that it has? And certainly you could change the window up a little bit and span this out with your fingers and look for other intersections. This actually is the only intersection that this has. If you take more math, you'll learn that these rational functions, some of them have vertical asymptotes and some of them have horizontal asymptotes. And the blue graph has a horizontal asymptote that's not the x-axis, whereas the green graph is sitting down there on the x-axis there. So I have a sense of what the long-run behavior is for really large x or really small x, and I know that the way that they're tending, they're going to tend away from each other. So, this is the only intersection that we need to worry about. But not knowing that, you could play with the window a little bit and kind of say, hey, is this the only intersection? And you'd probably figure out pretty quickly that it is. Okay, so the place where these are equal at negative 3.64, that is the x value that makes them equal, right? And we're solving this for x, right? So that's the value that we want. All right. So back here on the lecture notes, we've got, I was saying that x is approximately equal to negative 3.64. So says Desmos, right? So the solution set is negative 3.64. Okay, and some of these examples where you're solving with technology, they might have more than one intersection point. This one just had one solution to it. Okay, all right.